Share my screen. All right. Can everyone see this? Okay, cool. Let's see. All right. So hello. How's everyone doing? This is the first introductory lesson to the analog step sequencer project. So this is just a pretty basic intro. I'll talk about sort of a rough overview of the project and then ordering parts, but I didn't want to get into any specifics till you guys have your parts. And also this is a chance, like if you're still a little bit hesitant about whether you actually, want to do the project, then this will hopefully clear that up. So yeah. Oh, by the way, my name is Geffen. I'm a junior computer engineering major, and I'll be leading the project. And it's a pretty fun project, pretty straightforward. But if you have any questions at all during like now or later, just feel free to email me, message me on Discord about like other things too, like advice about classes, whatever you guys want. So yeah, let's continue. So live demo, actually, that's what I wanted to do first, because I wanted to show you guys kind of like what it looks like, what it sounds like. So actually, let me stop sharing really quick so I can change to this camera. Okay. So this is actually what it looks like. Hopefully you guys can see that kind of well. Let me just explain first of all sort of what's going on here. So you can see here, hopefully, there are a bunch of knobs, which are potentiometers, which you can use to control sort of different aspects about this. So these ones here in the front are essentially controlling the frequency of each of these notes when they play. Like it's not exactly what's happening, but sort of that's what you can think about. So if I like turn one of these knobs, it will sort of sound like higher or lower. And then there's these two other knobs here. This knob here controls that's just the speed of how the melody plays. And I'll do a demo in a second, but I just wanted to talk a little bit about it first. And then this knob here controls kind of like the pulse width. When we actually, I'll talk about this in a couple lessons in the future, but basically it controls like sort of the pulse width, so it makes the sound sort of sound a bit different. And then we also have 3 chips here, which I'll get into later. But most of the components here are pretty standard. There's nothing like crazy. And this is actually, I should mention, is a little bit of a modified version from what we're going to build. I was just experimenting to see if I could make the project a bit cheaper for those who wanted to just buy the components themselves. But we'll get into that later. So I have a speaker here that I'm hooked up to through this cable. I just sort of soldered these jumper wires on. But let me guys know if you can hear it, because when I was testing it yesterday, it sort of cut out a bit. So I'll just plug it in this battery. Turn up the volume. Can you guys hear that? Okay. Let's see. I wonder if how about now? All right. Well, anyways, let me turn this down a bit. Oh yeah, that's probably what's happening actually. So I'll just sort of show you what's going on anyways. These potentiometers are pretty small. They're kind of hard to turn, so I have this little like flathead that I can use to turn it. Hopefully you'll be able to hear this change, I don't know. But basically when I go like this, you'll see it sort of like turns deep, it sounds deeper. I don't know if you can hear that, but, and then this can be used to actually change the speed. So you can actually see it going slower. You may not be able to hear it, but then if I speed it up, and I can make it like really fast, but anyways, yeah, that's pretty much the gist of it. Let me switch back to my normal camera. All right, cool. So I'll probably post a demo of better quality sound so you can actually hear what it sounds like. It sounds pretty cool. It sounds like kind of like those old Atari games, if you know what I'm talking about. But yeah. So anyways, let's continue. I'll go on with the slides. Cool. All right. So today's agenda. Let me just sort of talk about. There's not really much to do today. I'm basically just going to talk. But I wanted to talk about first the project overview. You know, what even is this? Like, what is an analog step sequencer? Sort of how the lessons will work, and then you know, what do the next 5 classes look like? Because as I mentioned earlier, I don't know if any of you are still like sort of considering whether you want to build the project or not, but I'll talk about sort of what the next 5 lessons will look like. Yeah, and then I'll talk about how to get the parts if you're planning on just having me ship it to you, which is the easiest option. Then I will just send out a Google form and you can just put your address and your name and then your email, and I can also like send you the tracking number and stuff like that. And then also, I think the easiest way is just to do it over Venmo as far as for like paying for the components. But then also if you're buying the parts individually, I will also go over that and then sort of give you some tips, because buying the parts in bulk is like way cheaper. And I've been working hard to see if I could make it cheaper for those who are trying to buy individually, but it's some of these components, it's really hard. Like a breadboard is like kind of expensive. It's like $5, which is like a big chunk of the project. And also shipping, you know, that's already like another $5. So that's $10 and you haven't even bought any components yet. So it's kind of hard if you're purchasing it on your own. So I recommend, unless you already have a bunch of these components, like a breadboard and some jumper wires, to just let me ship it to you. Or, you know, you can just buy it on your own, whatever you prefer. But yeah, and then, you know, open it up to questions. Does anyone have any questions right now? Probably not. Okay, I'll just continue then. So first, so 1 second. Okay. So what is an analog step sequencer? So I don't think this is exactly like a formal name of something. I sort of just threw together this name, but in general, I'll talk about, you know, there's sequencer, a step sequencer, and then analog step sequencer. Sort of what the 3 sort of parts of this name really mean. So when I say sequencer, I'm kind of just referring, and if you look here on the right of this slide, like a sequencer is like something like a musical device. You can implement it in hardware or software, but and I'm sure like some of you have encountered this before, right? Like you can sort of just have a bunch of sounds or musical notes and then just basically play them sequentially. So like in this example on the bottom right, you know, I don't know if you guys have like done something like that before, but it's pretty common. What we're doing is a very simple version of that, because we have much less control, but it's pretty cool. And then so step sequencer, step basically referring to this idea that we have sort of these distinct, discrete, sort of evenly spaced tones that we step through. And when I say that, I basically mean, you know, we can't control how long each individual step plays. And there's only like an individual sequence, right? We can't overlay 2 sequences on each other. But that could be something like in the future, you know, after this project, if you wanted to expand on it, you know, you could add like additional circuitry so that you can control, you know, how long each tone plays for, or, you know, overlay 2 sort of sequences on top of each other to make, you know, more complex melodies. But yeah. And then analog is just kind of just referring to the components we're using, because when I first built this project, I did it using an Arduino, and in order to generate sort of the signals that we ended up becoming the sound, they were actually represented sort of in an array of values, in software, and then you can use something called PWM to actually, basically kind of like artificially generate these waves, right? Whereas here we're actually just using discrete components to do it. So yeah, cool. Let's move on. So how this is sort of a cluttered slide. I'll just kind of read through it, and all these notes will be posted later as well. So how the project will work this year. So in a typical year, we would meet, in a classroom, and it would be much more engaging. But it's remote this year, obviously. So there's a couple of changes. One is, everyone's gonna have to get the parts somehow. I can't really distribute it to you directly. So there is going to be like an additional shipping fee, which makes it more expensive, which is unfortunate, because I want this project to be accessible to whoever wants to build it. But it is what it is. And then obviously all projects are going to be held over Zoom. And then finally, I no soldering, because most people don't have access to a soldering iron. So we're just going to be building everything on a breadboard, which that's also a good thing to know how to do, to prototype and stuff like that. But then details. So there will be about 5 lessons after this one, in which we'll go sort of through every step of building this project. Even though it's pretty straightforward, I kind of want to dive deep into some of the different parts. There's some pretty, I guess, handy stuff to know, because like we're using quite a few components, capacitors, resistors, LEDs, diodes, potentiometers. We're using a few integrated circuits, which are pretty simple ones, and also BJTs actually. We'll talk about that in the future lessons, but yeah. So yeah, we'll talk about today purchasing components, but then every other lesson we'll talk about actually, each of the individual sort of sub circuits, and then we'll slowly build and combine them until we get the final project. And each lesson will be, about 45 to 75 minutes. And the first part is going to be sort of a lecture period where I'll sort of talk about the circuit, maybe a little bit of the theory, maybe solve some, sort of show you like solve for some of the values, and show you sort of the schematic. And then the second period will be a building period, which I guess will be more like an office hour, where I'll just sort of show you how to build it. It's going to be kind of hard to do it over Zoom, but I'll show you how to build it, and then everyone else will sort of build it along with me if you want. If you don't, you can build it at a later time. But sort of I'll just be here if you guys need any help with assembling it, because assembling stuff on a breadboard can sometimes be a bit finicky. So yeah. Oh, and then also before each lesson, I will send out a pre-reading, completely optional, but for those of you who are more beginner, these will be very helpful, because I won't have a lot of time to sort of explain some concepts. And also, like, I don't just want to be lecturing at you for like an hour. This isn't, it's supposed to be school. It's supposed to be like a fun project that you actually get some hands-on experience building circuits. So I'll send out some pre-reading material if you want to read that before each lesson, and I'll sort of help you understand sort of what's going on a more fundamental level. Yeah, and also, I mean, if you're more experienced, maybe it's a nice review. So that. Okay, now I'm gonna take a little look at what the next 5 lessons will look like. I just called this lesson 0 because we're not really learning anything today. So the first lesson, starting next week, is just going to be sort of an introduction to some of these electronic components we're using. Like I mentioned earlier, we're using quite a few, and we're going to build a couple sort of mini circuits that aren't necessarily like directly related to the final circuit, but some will be, some won't. Sort of just to get a handle on, how these components work, how you can build sort of circuits using them. And yeah, so Okay, and then lesson 2 will actually build on the concepts we sort of talk about in lesson 1 with those introductory components to build a more useful sort of circuit using something called the 555 timer. And that's one of the chips, one of the integrated circuits that I showed before. And so we're actually going to use we're basically going to build a circuit to generate a clock signal that we will use to basically control the timing in our circuit. And so the 555 timer IC is basically the most important component in this project. We actually use 3 of them. And I'll talk about more of that. I'll talk more about that, in the lesson. But yeah, that's lesson 2. And then lesson 3, we will talk about sound synthesis. Very basic. I'm not gonna, this is a pretty basic circuit. But we'll take a look at a deeper dive into how the 555 timer works, and we're going to use 2 of them to actually sort of generate these signals that will become the actual audio output, and it makes these sort of cool noises, and we'll be able to hear those through, if you have a speaker or headphones. I guess that's like something that you need if you don't have a speaker or headphones. But we'll have a little standard audio jack that you can just plug it into. So yeah, that's lesson 3. And then lesson 4 is I'll introduce another chip called the 4017, which is basically just a counter. And basically what that means is, the clock signal from the 555 will go into the counter, and it'll basically just count from 1 to 10. And it will do that by just basically outputting high on different pins. And then based on which pin is high, that will trigger a certain like tone in the sequence. And so I'll show you how we can, and so that lesson will basically just, hook it up to LEDs, and then we'll basically just light up these LEDs in a sequence. So that's lesson 4. And then lesson 5, we'll basically just combine the circuits from 2, 3, and 4 together, and then add some other components that we need to actually make this whole thing work. And also discuss the BJT and why we need to use it in this circuit. When I initially built it, I didn't use BJTs, and it kind of worked. It was kind of a hacky solution, but we'll discuss more about that in the future. So yeah. So getting the components, I sent this in the Google form already, but just a quick, or not quick review, more in-depth look at it. So there's 2 sort of methods. One is the bulk distribution method, which the majority of you selected, which is what I advise, especially if you don't have these components or are not really, maybe you're more of a beginner. That's what I would advise. But if you're not comfortable, for example, like sharing your address, then that's totally fine. But anyways, so that method will cost about $13 per person. The components are about like $9, if I remember correctly, and then shipping could be anywhere from $3 to $5, kind of depends. And hopefully all the components will arrive by the next lesson. So yeah, so if you want to choose this option, I will send out a Google form, where you can fill out your information, and just fill it out by the end of this weekend so I can know to send it to you so you can get the parts by next lesson, hopefully. And then method 2 is individual purchase. So that's basically if you want to just buy these components on your own. And so unfortunately, this is not as easy as just buying the same components, like the same links to the components, as I'm using the bulk method, because, for example, you can buy a lot of these components in bulk, but you can't buy them individually. For example, I ordered like 50 of like the 555 timers, for example, right? There's no, it's more expensive if you buy individually, and it's like a separate link, but like a separate retailer that you can get it from. But yeah, so I highly advise you to just go with the bulk method because it's cheaper and easier. But if you want to buy them by yourself, because you already have some components, then that's also great. I will go a little bit over how you can do that. That method will be anywhere from like $18 to like $22, $23, depending on the shipping method. So the $18 is actually, it kind of comes with a catch, because and the catch is that you can get free shipping from one of the retailers called DigiKey if you just send them your order in the mail through a letter with a check instead of online, and they'll send it to you for free. But the catch with that is it takes about, I did it a couple of times, it worked fine. Like I do it sometimes, but I don't really care about how long it takes to get my components, but it takes about 10 days to 2 weeks. So, you know, you won't have your components by next week, but you know, then you won't have to pay for shipping as well. So, but yeah, and then a couple more things I wanted to mention. Oh yeah, so if you want to do the individual purchase, you can, I've attached links and actually a cart in DigiKey, which is a retailer that sells electronics, where you can just order the parts and then, you know, remove whichever ones that you already have, right? And then hopefully it'll end up being cheaper. But if not, that's also fine. And then also, if you find any of the components at a cheaper price, you can let me know. But know that component availability and shipping fees and times play a major role, because I wanted to, you know, have parts that, you know, are widely available, because sometimes, like, you know, there's only like 10 left of them, right? I'm not going to put a link to something that not everyone can have access to. So yeah. Okay, now so at this point, if you are just going to buy the parts in bulk, like that's basically the end of the meeting. But if you can still stick around, I'm going to show you sort of, I guess, some tips if like if you're interested in like buying components yourself in the future. But also I'm going to look at the bill of materials. So up until this point, does anyone have any questions? Is this making sense? Hopefully I'm being clear.
I might have some of the parts. So is it still preferred to do $13 bulk?
Yeah, so I can just talk on an individual basis because it's like but it depends. It really depends. If you have like the breadboard is like $5, right? So that's like already takes a huge chunk out of it. But we can talk separately, and you can just message me. Yeah, anyone who is thinking of buying the components individually, you can just message me with what parts you have, and we can talk about, you know, if it's actually cheaper or not. So yeah. Anyone else have any questions before I move on? All right. So I'll stop sharing. Then I'll share a different screen. Okay. So this is the bill of materials. And I basically listed just all the components here, and they're actually very like standard components, right? Like there's nothing really special here other than maybe these integrated circuits, but like LED, potentiometer, resistor, capacitor, diode, right? Very standard components that you can find in a lot of places, or you might already have them if you've done some ECE labs. So let me just break down sort of the price. So what I've done is I've actually just created a cart in DigiKey. So if I just click this link, right? If you, I will send this out later, but if you click the link, it will just automatically generate a cart for you, and then you can just go and order it. You don't have to like select through these, but also, uh, yeah. So in total, these components are 1147, which is, you know, not super cheap. Because again, like if I look here, for example, at like, I don't know, potentiometers, right? If you buy 11, it's 245. But if I buy like 200 for like a bulk amount of people, then it's going to be like way cheaper, like per part, right? So, or like resistors, for example, right? It might be like 10, like here you can see like it's 10 cents per resistor, but when I buy 10 of them, it like reduces dramatically the price. So if I buy like 200 resistors, then it's like 1 cent per resistor. So that's why I advise to just go the bulk method, because then it'll just be cheaper for you. But yeah, but that's kind of why like this is more expensive than I would have liked. And also, you're right, there's tax, and some components have a tariff. And then there's also 2 shipping methods. So the first shipping method is just through USPS, and it's $5. And so your total will come out to $17.56. And bear in mind, this is without the breadboard. You don't see a breadboard here. And then the second shipping method is the thing that I was referring to earlier with DigiKey, that you can just send them a check in the mail. And so this 50 cents is just like a stamp, right? If you don't have a stamp. Oop. Okay. So yeah, so that would kind of be like the 2 options. Also, I've been working on another bill of materials from a separate vendor to see if I can make it even cheaper. It sort of depends, because like some vendors don't have certain components at a cheap price, and basically like the shipping drives everything, right? If I have to order from 2 separate vendors, then I have to pay 2 separate shipping fees, right? And then it's not even worth it anymore. So it's kind of a trade-off. And then finally, the bread. This is all if you want to buy it individually, not in bulk. So the cheapest breadboard I could find with wires is on eBay for $5.38. You know, if you already have it, then that's $5.38 that you don't have to pay, and then you would, I guess, pay these fees. But yeah, so in total, if you just didn't have any of the components and you just paid for the shipping, then it would be 22, which is like way more than 13, right? Or if you did the second shipping, then it'd be 18.45. And so really, this is not really worth it unless you have a bunch of the components. So for example, if you had like the breadboard, that's minus $5. If you have, you know, a 9-volt battery, that's minus another $2. You know, you have some of the other components, then it might be worth it. But, or, you know, if you can find it somewhere else for cheaper, but bear in mind that the shipping is like the main sort of factor into the price. And then also like, oh, someone typed in the chat. So the chips, so these chips are like super simple, right? Like, I mean, they're like only like, I guess, I don't think an 18 mega would work, because like we're just using, right, like these are just like simple, within these chips it's just like a bunch of like some simple discrete components. So like we're not really using like a microcontroller. So yeah, but I mean, I guess you could do it if you wanted to. Yeah, I guess. All these components are like general purpose, and these are like the only specific ones. Yeah, like you could use an Arduino, but I guess the point of this project is to use it's like a hardware project, right? Like when I first built this project, I did it with an Arduino, and it was kind of cool because, you know, it's from a sort of digital perspective, but this is more of an analog perspective. So yeah, you could do it if you wanted. That would be kind of a cool thing to do. Um, okay, yeah. Time, I mean, you could theoretically just assemble the circuit in like 20 minutes, right? So you can put as much time or as little time as you want, um, in the circuits, um, um, because like I'm gonna go like in depth, but like if you don't really care about how some of this stuff works internally, then that's perfectly fine. Each lesson each week is gonna be like 30 minutes, right? And then the other 30 minutes will be, or 30 minutes to an hour will just me be like sitting there and helping people build it. But you can build it whenever you want, right? This isn't like a standard class, right? This is kind of just something you want to do for fun or to get experience to build something. So but yeah, like if you have any more questions, please feel free to reach out. So yeah, let me, oh, actually I was gonna give you guys some tips on ordering parts if you're gonna do it individually. I guess just sort of as a show of how many people are thinking of ordering it individually. Hopefully, this clarified things and not confused you more. Um, yeah, I can share a final schematic with the cart link. Yeah, I'm gonna post all these notes. There's like I have all the notes already, so I'll post this after. Um, okay, so if you have any individual questions, you like just message me, uh, and we will talk about that. But let me go to a different page. Um, so stop sharing. Okay, so I guess now I'll just show you like in general, like I guess tips if you're trying to like order components online. But I assume if you're ordering the components yourself, you probably have some experience doing this. If not, that's also fine. So let me just share a screen really quick. So this is DigiKey. I personally really like ordering from them because they have pretty good parts, good service. Uh, Not necessarily the cheapest. There are other websites that may have certain components that are cheaper, but yeah. So for example, I'll just show an example of like how you would order a certain component if you were looking for it. So like, let's say I wanted the 330 ohm resistor, right? I could just type resistor in here. And then you can see it came with a million results. So that can be a bit overwhelming, but there's sort of like various levels of classification. So the first thing is we're building everything on a breadboard. So every component needs to be through hole. So if you don't know what through hole is, basically there's surface mount and there's like through hole are sort of like two main sort of I guess termination styles of components. If you're building something on like a printed circuit board and you're soldering it onto the printed circuit board, then you would want a surface mount component. But if you're assembling on a breadboard or soldering it into perf board, for example, then you want through hole components. So I'm just going to go through hole resistors, right? So that's now we have 500,000. So first thing we want to do is filter out, you know, the exact value. So I said like let's say 330 ohms. 330 ohms. And then I'll just click apply. So now you can see there's only 1,000 remaining now, but even then that's still a lot to sift through. So the next thing I'll do is price. You would think that the down arrow means, you know, the cheapest, but it actually means how it's sorted. So when I click the up arrow, it actually sorts it by ascending price. So from like least to most. So yeah, you can use a perf board if you want in solder. That's totally fine. As long as you're comfortable laying out the components and can figure it out, like that's totally cool. I just did it on a breadboard because most people don't have a soldering iron, and I just want to make the project as accessible as possible. So, but yeah, I mean, all these components, like they're through hole, so they should fit onto a perf board just fine. Um, yeah. Okay. So, anyways, so right, I sorted it by the cheapest, right? Because if you let's say you're just trying to buy the cheapest component, and you look at this and you're like, oh great, you know, super cheap, it's like less than a cent, right? But there's sort of a hidden thing here, minimum quantity 5,000, right? Also there's none in stock, so you don't want to buy something that's like you can only buy 5,000 of it. So first thing we're going to do is do in stock, and also going to enter view price set. So I'm going to say I want to like buy stuff individual. Now there's only 144 remaining, right? So now you'll see yeah, so I think this is the one I ordered. I don't know, one of these. But basically they're all 10 cents if you buy them by one. I think this is the one I ordered. Yeah. So if I click on it, I can see there's a bunch of details. There's the part number, the manufacturer, if you're curious about them, you can click the link to see if it's a good quality part. But in general, like it's a resistor, so yeah, not too much to worry about. There's a bunch of other details if you want to know like specifics, way more information than we really need. But so for example, right, one is 10 cents, and then this will show you the breakdown. And this is pretty standard for all websites. All websites sort of have this format for, or at least all electronic retailers will have this format of basically sort of that sifting through different categories, and then also like the price breakdown for how many you order. So the key here is that you can buy one, right? Some will start at like 5,000 because a company is not going to buy like 2 resistors. So if I type 10 here, right, it's not going to actually be $1. It's going to be less. It's going to be 36 cents because at 10 they make it basically way cheaper. So that's why ordering in bulk is like, for me sending it to you is probably the better option, because I can buy, for example, like 250, and now it's only 1 cent per resistor. So yeah, all the components you can find on DigiKey is what I found, which is why I used them. But except the breadboard. Breadboard is like $7 on DigiKey, which is why I did it separately. So, oh, well, actually, something I want to show you, which is cool. You can, you don't have to add all these parts individually. You can click this link, and it will just automatically create a cart for you. Because I made a cart, and then there's like a tool I have where you can just share a cart with other people. So now you can see I have all the parts in here that you would need. Something to note is that these potentiometers are kind of not the best quality. So, and you kind of have to chop these leads off. So, but I mean, they're really cheap. So if you want to buy like for the bulk order, I ordered a little bit nicer potentiometers, like these guys. They fit into the board nicely, and they're just a bit easier to work with. Like you can actually turn them with your hands instead of with a flathead. But yeah, this is sort of like the cheapest I could get it to within a reasonable amount. But like other websites, for example, like would have BJTs for cheaper, or some of these other components for cheaper. But DigiKey is usually really good for if you want to buy like simple chips. They have a lot of good options for very cheap. But yeah, you can see here there's pretty much all the components except for the breadboard. But like, if you have like a 9-volt battery at home, then it's much cheaper. But yeah, or also, yeah, another thing I want to mention, you could add this cart and then just remove the components that you already have and see if it ends up being cheaper. And then the method for, oh, someone typed in the chat. Would you be willing to customize the orders you ship out so we can only request them? So for the bulk order, I mean, I guess it would only reduce by like 50 cents, but I guess if you care, I guess I could do that. Because like I can't buy like, for example, like 37 of something. It only comes in like 25, 100, like those. So talk to me individually and we can work it out. The point is, like, I want everyone to have access to this project without having to spend too much money. Like ideally you wouldn't have to spend any money, but yeah. So yeah, talk to me individually and we can figure it out. But what did I want to do? Oh, so the shipping method for if you wanted to just send them a letter so you didn't have to pay for shipping. So if I just go to my desktop, order. So you have to actually ship them in order form. And I already filled out all the components for you with all the pricing. So if you wanted to do this method, right, and you didn't care about waiting a couple of weeks for your for your parts to arrive, then you could do it. And if you have any of these, you can just remove them, and that would make it even cheaper. So for example, all you need to pay is $12.57. That's it. No shipping at all. They will pay the shipping for you if you pay using a check and you mail them this letter. So for example, if you had like a battery already or some of these components, and it'd be even cheaper, probably around like $10, right? And if you had a breadboard, then this would be the cheapest option, but you need to wait 2 weeks. So I can send this form to whoever wants it, but other than that, that's pretty much it for this. Oh, let me stop sharing. That's pretty much it for this meeting. I will stop the recording.